vamos a presentar entonces este primer bloque de estas jornadas, que en principio tocará el tema unos y ceros, cero problemas y un túnel digital, flujo de trabajo para un gemelo digital desde las etapas iniciales de diseño hasta las etapas posteriores a la construcción. Va a hacer uso de la palabra el licenciado David Grebenstein de Geoconsult. El licenciado Grebenstein tiene amplia experiencia en geociencias, teledetección y construcción en proyectos superficiales y subterráneos, modelado subterráneo compatible con BIM 3D, superficial, enfoques explícitos e implícitos, documentación geológica e hidrológica de túneles, documentación geológica de ingeniería de tajos abiertos. Es operador certificado de explosivos, planificación de voladuras y voladuras. A continuación, se va a tomar el tema nuevas tecnologías digitales en obras de infraestructuras, detalles y aplicaciones. El uso de la palabra será de Franz Weichenberger. Es geólogo, desarrolla su actividad como ingeniero geólogo, hidrogeólogo y desarrollador de software para el grupo Geoconsult desde enero de 2017. Recibido en el 2001 en la Universidad de Salzburgo, en Austria, Instituto de Geología y Paleontología, estudios de maestría, documentación geológica y supervisión de edificaciones de túneles, estudios de variante y viabilidad de proyectos de infraestructura, centrales eléctricas e infraestructura turística en todas las fases del proyecto. Estudios geológicos e hidrogeológicos para evaluaciones de obras, de peligros, riesgos para bombas de calor cercanas a la superficie. A continuación, se tomará el tema creación de una estrategia digital para garantizar el mejor valor para grandes proyectos. Eficiencias de tiempo, proyectos optimizados, calidad y eficacias mejoradas, reducción de los costos operativos y de entrega del ciclo de vida, riesgos reducidos para clientes, inversores y desarrolladores, hacer que los activos sean más fáciles de administrar y más atractivos para alquilar, vender o retener. Va a hacer uso de la palabra, en este caso, Malcolm Taylor, de Crossrail Reino Unido. Malcolm Taylor es Bachelor of Engineering, Chartered Engineering, Master of Business Administration, Member of IC, Member of the Institution of Structural Engineering en United Kingdom. Más de 40 años de experiencia en gestión de programas y proyectos, diseño y construcción de los principales esquemas de infraestructura de transporte en todo el mundo y máximo exponente del Reino Unido para la madurez del Project Information Management y Building Information Management en organizaciones de clientes utilizando tecnologías digitales. Se desempeñó como jefe de información técnica para Crossrail, el proyecto de infraestructura ferroviaria más grande de Europa, un modelo de mejores prácticas en el Reino Unido. Y completó además 2 asignaciones de 4 años en Hong Kong, en Mouchel, ahora WSP. Finalmente, tomaremos el tema buenas prácticas para el proyecto y explotación de un túnel mediante la metodología BIM, caso particular del túnel de Caldearenas, en el puerto de Monrepós, A23, Huesca, España. En este caso, va a hacer uso de la palabra Rafael López Guarga, ingeniero jefe de la demarcación de carreteras del estado de Aragón, que pertenece al Ministerio de Transporte, Movilidad y Agenda Urbana. Rafael López Guarda es ingeniero de caminos, canales y puertos por la Universidad Politécnica de Madrid desde 1977. En 1986 se incorpora al Cuerpo de Ingenieros de Caminos, Canales y Puertos del Estado para trabajar durante 8 años en la empresa privada en los sectores del transporte y construcción. En la actualidad es jefe de la demarcación de carreteras del Estado de Aragón, en el norte de España, que depende del Ministerio de Transporte, Movilidad y Agenda Urbana. Es además responsable de más de 2.500 kilómetros de carretera, de los cuales aproximadamente 50% son autopistas y autovías. Bajo su responsabilidad se han construido y están en explotación más de 50 túneles, incluido el túnel binacional de Somport entre Francia y España, que con sus 8.600 metros es el túnel de carretera más largo de España, La mayoría de los otros túneles están en el rango que van entre los 600 y los 3000 metros. De esta forma, entonces, presentamos al primer bloque. No sé si el ingeniero Bardé entonces toma la palabra. Será su moderador.
Muchas gracias, Gabriel, por la presentación, que me ha ahorrado un buen trabajo en la lectura de tan distinguidos expositores. Y entonces damos lugar a la primera presentación del licenciado David Grebenstein. Please, David, take the word, please.
Hello, does everyone hear me?
Yes, please.
Okay.
We hear you too well.
Okay. Thank you very much. Muchas gracias. And hola, ¿qué tal? That's practically all my Spanish I have can share with you. Okay, so I was asked to do a little bit of an introduction to the whole BIM digital means and 3D modeling. And I try to stay very on the low end and try to pick up everyone not so much involved. So let's start with my first question. I try to always ask questions and answer them myself then. So my question is the digital tunnel a twin from the future? And what would one expect from a digital twin? Okay, so I thought of, well, what one would dream of is that we have all the designs, really all designs in one particular place, all the tech documentation that starts from the switch which turns on the emergency lighting to practically the rock quality measurements made in the lab 2 weeks ago, everything in one place. So all disciplines are contributing and they are all working in one common data environment. That's called a CDE. And this is practically already feasible and working well in several projects. We have interconnected data storages. Everything is available online. So if you are out in the field and need to check something, just get your internet connection up and running and get your browser open, and then you can access all the data. But also if you're in an office or in a presentation and you see, oh, we need to update something, or we have a new idea where we have to check some certain piece of paper or a document, we can just load it, see, and the discussion goes on without worrying about too much about data. A feature what one would love to see maybe is a live and up-to-date data. So for example, if the project manager has to report to some authority and he wants to see how far are we in the tunnel? Are we at tunnel meter or chainage 500, or are we already at 560, where our special area and the transition is starting? So you can just check it up and look at it. So the next question is, what is digital? I mean, that's a straightforward question, and but it's not really so much straightforward if you come into data handling in BIM terms and in modeling terms. So I tried to illustrate here this a little bit and made some examples which are good examples, which are bad examples. For example, databases which are clean, well-maintained, or machine-readable data in CSV format, or maybe log data from a borehole log. It's very nice. And on the other hand, there are also digital data, which is maybe still digital, but not really useful, except you put some more work into it. So I put in here maybe data without reference, overcomplicated and non-clear spreadsheets, for example, with joint cells, and you just want to read them in. This is something new, and one has to adapt to make it more clear and more unique values in any case. So the first result is all the sample data we want to put in has to be digital, but also digitally usable, so machine readable for that matter. So why do we do all this data collection? I mean, this is very obvious. I just want to repeat this. We need all the data at hand for public understanding, tech-to-tech communication, so technician talks to another technician, and all other combinations of this. We want to do some collision checking. I'm just thinking about geotech, geological, hydro, and plant structures, which are combined and can collide with each other, or features of the models themselves can collide. For example, if we have an area where we have to expect high water ingress and we want to build some open cable trough here, maybe not as feasible. And only if we connect the data and overlay it, we will see that there's something maybe not so good in our planning. Optimization, I mean, this is the next step, obviously, and we can avoid challenging situations because we understand our tunnel and our subsurface model so much better, and because we combine everything. I mean, sure, this is a thing we have done in the past, but if you want to overlay 3 pieces of paper, this is already getting a book. And if you try to look through a book, I mean, it's not so feasible. But if you have 3D models where you can change transparency and overlay them, and suddenly you see issues which you have not seen before, and can make the whole team aware of those. Does this mean we have more work to do? Sure, in the beginning. There is, to some extent, the on-lap of the project, you need to take more time. I think that's necessary. But as we have the full amount of data already prepared and referenced and put into, I say, a nice data frame, then we can profit from this the whole project long. And this maybe has to also be taken in consideration if you have if you give a project out to for example a consulting office, and they say, okay, we can do this, but expect them to have the time and the needs and also the money, that they have the time to put the project on a superb and full foundation. I think this is very important, and this changes a little bit because you don't do so much overlapping in the long run, but in the first place you have to set it up correctly. Why do we do this throughout the project then? And we can set it up and then it's, if for example in the planning stage, and then it's useless, is it? No, because we see, I just tried to illustrate here a little bit what different stages, and I try to keep them as arbitrary as I could think of. So we have the idea, and then we have to plan. We have the details coming in from some engineer who has worked in this area before. Then we have, again, some planning stage. We have technical problems. Okay, again, planning stage. We have some political maybe challenges because we have to move the route or the alignment somewhere else. Again, planning. If we have only analog and paper-based systems here, we create a huge amount of data which is obsolete. And with the digital means, we can just adjust the alignment and create new sections, and we save a lot of time and thinking energy. And this helps us to concentrate again on the issues we're gonna have, because no project is gonna be smooth sailing because we have sandstone all the tunnel through and there's no problem, no water, no gas, no nothing. No. We're gonna have problems in every project. So we can concentrate now on the projects we're gonna see. And I mean, this also, these 3D models, they are so much more easier to understand for the whole group of people who are in the project. So it's not only technicians or engineers like ourselves, but also we have the stakeholders who might not be have may not have an engineering background. These people we also have to pick up, and we have to think how we can transport the information they need to make their decisions, or how we can convince them to make our decisions. The same applies to politicians, landowners, group with agendas. So yeah, let's have a look at what could happen in a planning stage. So we have our just think about a cavern with some access tunnel, and we want to build that. And we have, like in here in the little illustration, we have the problem that we have some fault zoning in area A and nothing in area B. So we automatically see that the movement of the whole situation, just by moving it some 500 meters to the west, maybe, we are out of the problematic zone, and everyone can see this. Maybe we have to build 200 more meters of access tunnel for this project in particular, but everyone, even the non-engineers, will automatically understand, okay, in this area there are the blue lines, but they don't necessarily need to understand that the blue lines mean some special fault zones. They just see blue lines, there's something with our cavern which we want to have. We move it to the side. We need a little bit more access tunnel because the access tunnel is much more easier to build through some fault zones. So everyone understands, and everyone realizes, okay, we need a little bit more money for this. They understand the need for it and can accept and give the funds for this. And that comes without saying that you can do some risk and cost risk analysis with this as well. So now the second question is, now we are in maybe in a construction, the construction is underway. What's going on here? What can we do here with the 3D models? We have the full access to all the data available at the moment at hand, and as it is digitally, we don't need to update anything and send new plans because it's still in the CDE, so the central data environment. So if a new project engineer comes to the construction site, he has to have a look at a CDE, spend some afternoon on this, and then he's already has the 3D visualization of the project, and does not necessarily have to adjust and adapt to what maybe 5 sections in a row means to the project team, which are already maybe half a year on site. So that reduces friction by a substantial amount. That also means that maybe on-site, off-site teams can just communicate so much better. Second thing for the construction, maybe we have some undocumented, not seen challenging situation, maybe like some water ingress or some material which one has not anticipated in the prognosis. So maybe we need an umbrella, or maybe we need some injections to push back the water. So we can visualize our success by visualizing maybe the amount of cement which went into the face, or maybe went into the wall. And then we see where we have to maybe put in additional support. And as this is all visualized, the engineer from the company who supplies the cement and the rock bolts, for example, he sees what the success was on site. He can give better hints and better advice. And also the project manager sees where is the money flowing, what we have put into the project so far, because an unforeseen event is usually connected with more money. So everyone knows transparently what is going on. And the transition to operation, we have a huge advantage as well. So we see that we have a documented, so we have a planned model, we have as-built documentation. My colleague Franz will later on talk a little bit about this. And we have maybe a updated model from our prognosis. So we have maybe 3 models, one big of the mountain, one small one just for the tunnel, and one again updated for the mountain. So if we have questions now with additional costs, because we say, okay, we have seen some sandstone filled with water and we had so much ingress, the construction company wants now some more money. We do understand that. We have our documentation at hand. We see what we knew when we started. We see what we knew in the planning stage, and we also see what was there when we arrived at a particular position. So it can be a fair process of billing the construction company. We can also check for areas of interest for the operation, where we had some water, where we had gas, where we had permafrost, for example. Just bear in mind that these documents maybe get lost in the drawer if they are on paper, but if they still stay on the CDE for everyone to access, even 20 years later, the engineer who's responsible for maintenance can just go there, have a look and see, okay, they had some sandstone there, the water comes from that. Okay, I do understand that now. No problem, we're going to do this, that, and then we are out of the red zone again. So how does a workflow like this will look like? Okay, so we have in the center, we have the modeling software, and around it, there will be some silos of data which fill in the data. So for example, GIS databases for boreholes, databases for text structures. And we have also from the construction phase, we have on-site documentation, maybe some tunnel GIS. And then we can output the IFC format. The IFC format is to be considered like a PDF format. It's universally readable. Everyone can use them. And then we can put these file packages on the CDE, so the central data storage, and everyone can combine the data packages. For example, the data package from construction, the data package from the electrical guys, the data from plumbing, and the data from subsurface modeling. Everything can combine and then be visualized at the same time, or depending on the complication, not visualized in that case if it's too much. So what can we use? What are the outputs? Well, this is straightforward. We can use sections, volume bodies. The volume bodies can be used for several packages in the aftermath. So for example, FE modeling for maybe some structural testing, modeling and designing. If you think of the subsurface modeling, but also the subsurface volume bodies, for example, if you have a sill or a sand or some gravel, and you can put it directly into your groundwater modeling package, and you can save time because the data does not has to be put in 2 times. So for example, one time the groundwater guys are defining their boundaries, but at the same time, the same material has already been modeled, so you can save some time here. Outputs, yeah, well, standard output files. What I would love to put some emphasis here also is the communication part, because communication with externals is quite important, as we know. I would shed some light on 2 things. The first thing is 3D printing parts. I hope you can see it in the video as well as on the screen. So I have here some tunnel, which consists out of several layers. And this, for example, just a fold with a fold core in it, or you have some other pieces which just look like pieces of a mountain. And in my experience, firsthand, if you have issues with groups, if you have issues with landowners, if you have issues with politicians, because they don't understand the issues at hand and don't understand the problems you're in, it's very easy to just give them this piece of 3D print and they can put it together like so. And then they suddenly understand and okay, this is the mountain I'm living on. This is the problem we are having. And this sound a little bit silly, but as soon as people touch and have this tactile feedback from something, they start to reduce the amount of the defensiveness and their aggression sometimes. And we can use that if we have critical and very difficult diplomatic situations where we have to discuss certain features. Suddenly people tend to be more relaxed and understand that there is a technical issue which we are now discussing, not any more problems. They see the issue and try to be involved in the solution. This is just my personal experiences. The same applies to VR visualization and workflows. If you set the goggles, for example, Oculus Rift or Valve Index, for example, you just set them on a person or and that may be an engineer who's new to the project, that may be some landowner, that may be a politician. If they see the whole project and the problems in virtual reality, they tend to understand the issues so much more faster. And there's not much discussion about what is really going on, because as soon as you tell them maybe, okay, we have a dolomite and there's interlaying some marble and below there's some sandstone, they already shut down and don't understand anything anymore. And there you can just pick them up and tell them, hey, look, fairly easy. You look at the yellow thing, look at the brown thing, and below that there's the blue thing. Imagine this, imagine that, imagine that. And suddenly they can have the image which the engineer has automatically in his brain. It's just there. And you can start talking about solution and not problems, or even explaining what the real problem is. This will create higher customer acceptance. Also team-to-team communication. So for example, if you have one on-site and one off-site, and engineers in the main office do something new and have a new idea what the problem solution is, and the on-site guys have the same thing, and then you can discuss this, because with these VR goggles, you can create virtual rooms where you look at the same model at the same time, and no problem here. Because it's fairly easy to communicate. And one guy can, for example, be in Singapore, the other in Abu Dhabi, and the third in Buenos Aires. You only need to find a time slot, and they don't have to fly across the globe. This is all already yet feasible and doable, and it's very easy. It helps a lot. Really, it helps a lot.
I'm sorry, David, you have 3 minutes because we are sitting the time. If you could arrive to some conclusion, you have 3 minutes.
I'm just there. I'm already.
Okay. Thank you.
What is the? I want to wrap this up. So, what is the recipe for good models? We need good and high quality data. We need reference data. We need it machine readable. We need good personnel, because these 3D means are not the holy grail. They are just a tool which helps us, especially with communication, maybe also with some technical issues. And we can identify areas of interest which are posing problems for us. And we have so many tools to have a full picture of these issues and use them as a tool to identify and solve the problems. I would love to end with the stupid saying, a picture is worth 1,000 words, but this really applies also to the 3D models. And I would say a 3D model is worth 1,000 words. Thank you very much. Muchas gracias.